So, hello everyone. First of all, I would like to thank OpenSSF for giving me this opportunity to speak at this event and present work that our team has been doing. So, before even going to the talk, right, I'll just like to first introduce about myself and how does this idea came in picture. So, I'm a security engineer, also a bug bounty hunter. Plus, I also build tools, and I've been around bug bounty space, security engineering space, plus organizing events at our city as well. I've been into security for like over 7 years, doing CTFs, doing automations, and building tools for the community as well. Um, no, before even going to the talk, right? How did this idea came in picture, and why did this matter to us? I think that I would start about, right. So you would have seen like from the past, I would say 5 years, how software supply chain issues have caused like a global impact. Generally, if you would see, right, before that, like people used to consider that okay, there's a library, there's an SDK, we are using this, but what's about it? Like, what's the security around it? People were considerate and people were cautious about it, but to amplify that, right, or to make something in action, generally security awareness, like adding security awareness in action, an impact is needed. It's a bad impact, but still you can see like these chain of events, right, triggered a lot of impact downside to all the companies globally. It didn't affected just single company, but any company globally that were present were affected by this. When initially Log4j in picture, right, it was a nightmare on a Friday. So everyone of whoever is present might know what Log4j did to everyone in the winters. But this didn't stop, right? Even though when Log4j happened, a lot of protections were taken in place by a lot of community, like package managers, and even I would say at global level, like how packages are designed, how pushes are allowed, how anyone can push the code. But even if you see, right, in 2025, the recent one, TJ Actions, right, how much impact did it had? So this idea just came in picture that how about we think about a problem that dependencies are present, but how do we solve it in a way where organizations can adapt to it? They can easily come in and say, okay, in our pipeline, how do we solve off identifying what are the dependencies and how do we determine if it is vulnerable or not? So this is, I think, what was the initial idea, and why does this matter is like basically as I earlier talked about, right? Not just from the perspective of like how you could be attacked, but it also had downsides as well. Right? If you think it from a perspective of organization, any organization, let's say profit, non-profit, right? You have a reputation in generally, right? And anyone coming in and impacting your whole organization, stealing your data out of it, right, impacts a lot to your org, and it majorly impacts the security team. So that's also an idea we came up with, right? Security, it should be easy for security teams plus developers to just plug and play in their whole pipeline. So this is, I think, from the one that Alex Birson had published a blog, right? How he was able to hack into Apple and so many companies just from showing that one dependency that is internal but is also not present on the public package, and how he was able to take over so many of them. So I'll also give an idea about people who are not aware of how this attack works is. So suppose there's a library, there's an SDK, there's a package that you are using as a part of your code space. And now that you have determined there's let's say there was a package that was being used in a public space. Now someone is not maintaining, and let's say it's being deleted right now. And once it's deleted, someone else has gone up on the package manager and claimed that package. And once it's done, what would next happen is if they publish a new package or if they modify the package generally, from the new install, like whenever you are building a production code or whenever you are making changes in production code, this library will be installed. And if it has a pre-installed script, from example Node.js, even in Python, right, or in any other ecosystem as well, if it runs, so it's a direct code injection in your pipeline. So also a further idea of how we came to this conclusion that why we need this tool first of all in place. If you see, there are a lot of tools generally right now present in the market, which are solving like dependency confusion. There's one by Visma, there's one by Confuse, something called Confuse. So these tools are present. So why this tool generally? So what we found that it's good for example, like it's a is if you have a system where your organization is just using Python, it's just using Go, it's just using Java, it has like one or two ecosystems, right? It's easy for those tools to come in picture and adopt to it. For example, with Visma, what you would see is it might not be able to solve for multi-folder things. For example, the reason I would also talk about in later is like why SBOM? Like why are we solving at the SBOM layer? Why not, let's say if you have a code, right? Why not you take requirements.txt? Why not take package.json as a source of truth and just act upon it? Yep. So making it industry standard, right? So for example, using tools like let's say CycloneDX, right, and other tools, what it does is gives the entire SBOM out of your code space. So once you have that SBOM, right, that is what our tool is consuming. And because it's a standard practice in picture, we thought that just consuming SBOM as a source of truth would be a central idea instead of using requirements.txt or package.json as a source of truth, and then building vulnerable, declaring a package is vulnerable or not. And that is how it would help solve a lot of problems for production code. So that's where our idea came in picture, and that how DepConfuse was created. And another challenge was like, how do you manage each and every ecosystem? Because as I earlier mentioned, right, one tool can solve for 2-3 ecosystems. If you look at the current tools, you would find that it's not solving for every package that is available, right? So that's how SBOM also comes in picture, where SBOM is a standard industry package, like a practice. And once you have an SBOM or like a Perl list, right, it's easy for you to have a standard picture in place where you can have a second layer on top of that. Yes, and uh, yes. Yeah. So I will talk about how DepConfuse also works is right. So for example, in your CI/CD, so generally our recommendation is using this tool as a part of your CI/CD pipeline. First trying it out on your UAT or your staging environment, then moving it on to production. So the input sources that our tool takes is an SBOM or a Perl list. Then we have what our tool does is it has an input parser. Then we use ecosystem-MS API, basically where we check that from that SBOM list, right? Whatever the packages version that is listed, is it vulnerable or not? And the reason we are using ecosystem-MS API because we found it most reliable. It has most number of updated packages in the sense, and this gave us the maximum result when we are comparing and benchmarking multiple tools in general. And once that process is completed, right, it checks for every package, it would return the result, and the results could be further consumed for displaying it on a dashboard, mapping it out to your own CSV or things like that. Now I will quickly show you a demo of our tool as well. So to give you an idea, I already have like if a samples folder, for example, I can show you. So we have an SBOM and a Perl. I'll later show you our GitHub link also. You can just go and try it out as well. So for demo, what we'll do is run it first on the SBOM part. So as you can see, right, using the SBOM file, it is querying the MS API, and we have also built it in a way like it's scalable and it's fast. It's written in Go from the design principle, keeping in mind that while we are trying out which language to build upon in, we thought of putting it in Go because we found that general concurrency that we were trying to achieve was near to much more better in terms of Go using Go than Python. Uh, so that's the reason also we use Go. And once it's completed, right? So I'll also show you one sample command. So it says like it takes an input of SBOM. Here you can also put in a Perl list, and you can also define output. So generally, another idea and another roadmap for this project is like using few other factors as well, right? For example, right now you have seen that this would just give a vulnerable, is a package vulnerable or not? But what about actual impact? How do you assess actual impact of what this package can do? So as a future roadmap, what we are trying to do is implement EPSS, which would actually give you in last 90 days, what was the exploitability for this package? Basically, how we would do is based on the package vulnerability, right? If it has a CVSS, if it has a package CWE, right? We would map it out and then declare, okay, this was exploited in the past 90 days, and this is a score of under 10. How much? So this is the most in the sense of priority. How do you prioritize? Because like even if you implement something in your organization, your next major challenge would be how do we take action on that? So that's our future roadmap where we would actually implement and tell you, okay, this is something you need to fix it now. This is like P1, P2, and things like that. So it would take time, but as a part of demo, I would just wanted to show you like this is vulnerable, and if you would want to, let's say, go check out our tool, I would also like we have a link later. But as a part of prevention, I would just cover a few more things apart from this. As you can see, these are general recommendations also, like package name reservation, like reserve your internal packages namespace earlier, namespace implementation as well, continuous monitoring. Plus, one of the latest things that I've seen being done and where this is not taken care right now is like as a part of a developer awareness as well, where let's say, right, what I've seen recently while doing bug bounty, I've observed this. In popular ecosystem, for example, AWS ECR, Docker Hub, and few places, what I've recently found was developer credentials were generally available for these package managers as well. So this is also an entry point where developer credentials via ECR and Docker Hub are giving direct access. We are giving a talk next DEFCON on this specific topic. So I would stop that for there. But that's also one of the areas like where developer credentials are directly hard-coded in public images. So ideally, a solution we are building that for future. But that was for now. If you want to try our tool, this is the link. You can go and check out our tool. And if you have any feedback, you can reach out to me on Twitter or LinkedIn. Thank you.
Thanks, Akshansh. I think that was very useful to learn about how you're putting SBOMs to use in production. And with that, I think we come to a very important part of the day's event, the break. So I think breaks are wonderful. It's a time to recharge. It's a time to connect with all of the speakers that you saw on stage, but also introduce yourselves to each other. There's some snacks that are served outside the door. Please help yourselves. We're giving ourselves about 45 minutes. So hopefully I can see all of you back in the room at 1:30, so that